For this lesson, I want to talk about a system of linear equations. So off to the left, we have 2x plus y is equal to 1. Call that the first equation. And then negative x plus y is equal to 4. That's my second equation. So if we look at each one individually and graph it, the graph represents all of the solutions to that one equation. So it's starting with the first one. 2x plus y is 1. If I subtract 2x from both sides, this thing's very easy to graph. It has a y-intercept of 1, a slope of negative 2. So just like as a really simple sketch, here's my graph. It's not perfect, but that represents every solution to the first equation. If you look at the second equation, that's negative x plus y is equal to 4. If I solve that one for x, I get y equals x plus 4. So this has a y-intercept of 4 and a slope of 1. So this represents my line. The green line is every solution to our second equation. And the thing to notice is that these two meet at this spot right here. What looks to be negative 1 for x and 3 for y. So this point is on both lines, and that's what we mean by a solution to a system of equations. It's something that makes both equations true. So this is actually the answer to the problem. It's negative 1 comma 3. I can see it in my picture. If I want to check this, I'll plug it into both equations. So I'll check the first equation. That means I put negative 1 in place of x and 3 in place of y. And that's negative 2 plus 3 is 1. And, well, that's 1 is equal to 1. Okay, great. Negative 1, 3 definitely works on the first equation. If we check the second equation, okay, let's see, that's negative 1 in place of x and 3 in place of y. Is this equal to 4? Well, that's 1 plus 3 is 4. 4 is in fact equal to 4, so it's also true there. So to be a solution to a system of equations, it's some point that makes every equation true. So you can think of this as the place where the two graphs meet. And that is it for this first part. So that was kind of a lot of work to get the solution. You know, we had to graph both lines and find their intersection and plug in the points to see if it was true. Another approach would be to not use a graph and just use some analytic methods. And one of those is called the substitution method. It's a way where you can just work with the equations and substitute one into the place of another. So, you know, going back to the very first example, I have 2x plus y is equal to 1 and negative x plus y is equal to 4. If I take the second equation and I solve it for y, so that was, I believe we got y is equal to x plus 4. So this is coming from the second equation. I can now go back to the first equation, which is 2x plus y is equal to 1. And wherever I see a y, I can replace it with what it is equal to in terms of x. That means I take 2x, and then wherever I see this y, I'm going to plug in my second equation, which is x plus 4. So it's called the substitution method because I took one equation, solved it for y, plugged that information into the second equation, and wound up with this thing here. 2x plus x plus 4 is equal to 1. If I go and try to solve this equation, this is 2x plus x plus 4 is 1, or 3x plus 4 is 1. If I subtract 4 from both sides, I get 3x is equal to negative 3. And if I divide both sides by 3, I get x is equal to negative 1. This is the x value that we got in the previous example. Now you need to know what the corresponding y value is too, but we have this equation here that connects my x values and y values. So to solve for y, I'm going to put -1 in place of this x. So from here we have y is equal to -1 plus 4, and therefore y is equal to 3. So we got x is equal to -1, y is equal to 3, and this matches up with our previous example. So here's a way to solve a system of equations without using a graph or trying to guess the solution. Take one equation, solve it for a variable, and then plug it into the second equation. And for the second example, here I have a system of equations again. 10x plus 3y is equal to 8, and 4x plus y is equal to 2. So we could solve this by taking the second equation and solving it for y, and then plugging that information in place of this y to solve for x. But there's another method called the addition method. So instead of like substituting something in place of one of the variables, what you do is you actually add your equations together, but you want to try to cancel one of the variables in doing so. So if I look at these two equations, if we were to directly add them together, so like 10x would add to 4x to give you 14x, 3y would add to 1y giving you 4y, and then on the other side you would have 8 plus 2 is 10, like nothing canceled for us. But the observation to make is, if this y was a -3y instead of a y, if we added the two equations together, we'd have 3y minus 3y would be 0. So if that happened, this would become a very simple system of equations. So the goal is like, okay, what could I do to have a -3 sitting right here? And the answer is to multiply this entire second equation by -3. So I'm going to write that down. We're going to take this equation and we're multiplying by -3. And I'm leaving the very first equation alone. The first equation was 10x plus 3y is equal to 8. And the second equation, if I multiply through everything by -3, I get -12x minus 3y is equal to -6. For the addition method, what you do is you now add the left sides together and you add the right sides together. Let's see what happens. Okay, so we have 10x. We're adding this -12x. The result is going to be -2x. Here I have a 3y. I'm adding this -3y. We've already decided, oh, okay, well, that's just 0. I'm not going to write anything. And on the other side, I have 8 plus a -6, and that's going to be a +2. So like really quickly, we got to -2x is 2. The only thing we have to do is divide both sides by -2 to get our answer of -1. If you now want to know the corresponding y value, I'm going to go back to this very first equation we looked at. I'm going to put -1 in place of x and solve for y. See what happens. So we have 4 times -1 plus y is equal to 2. So that is -4 plus y is 2. Adding 4 to both sides gives me 6. The solution to this system of equations is -1, 6. And this is the answer to the example.